Good morning, gentlemen. Today we are going to tell you about the mini project which you are supposed to do. Let me make it clear that unless you finish this mini project, you will not be given the certificate that you have undergone this course. So it is mandatory that you finish this mini project and submit it to us within the stipulated time. We are providing you with this video so that you get more idea of how to go about doing this mini project, and how you have to do it has been made clear to you, but I will just go over through it one more time. So you have to use your login to log in into thinklabs.ipintentia.com and select the 12th module, which is the mini project. In this, the whole setup is done and you have to just follow the instructions to complete your mini project. A lot of details have already been provided in the instructions, but I will also show you some code so that you understand where you have to apply these things that are written. So as the instruction says, in this project you are expected to implement a monitor for checking the counter functionality automatically. The objective is to test your ability to understand a design requirement and implement it on its own. Currently we are implementing a monitor which is part of the test bench, but it can as well be RTL which you want to develop on your own. We will provide you with guidelines on how to approach this activity. Now let us go to the next instruction. As with the tasks, you may decide on the ports of the checkers first. So this is very important. First you need to decide what ports should go into your design. So as you are going to monitor the RTL continuously, it's very clear that all the RTL ports should be there in the checker. All RTL and test bench interaction signals will go in as inputs to the checker. It will monitor these inputs to verify RTL functionality. As a consequence, a large portion of the monitor code will be similar to the RTL. However, we will highlight some key differences. So here, as you can see, we have given a dummy template of the monitor that you are going to do. And then you have the test bench. So looking at the test bench, you can see what are the signals of interest. Another test bench is fairly simple. The main interaction takes place between the func driver and the actual RTL, which is the mult counter. Both of them have the same set of ports. As we look at the mult counter, this is our RTL. Note that what you have said over here, a large portion of the monitor code will be similar to the RTL. So the RTL is a good point to start off the monitor with, but there are some key differences which we will tell you as we go ahead. So let us move on to the next instruction. So here we see, as always, the first step involves checking for correct register read-write operations. The register write functionality in the monitor will be identical in the RTL. Therefore, the monitor will include two registers, control reg_mon and period reg_mon. A write operation on the RTL registers will result in a write operation in the corresponding monitor registers simultaneously. So we are using the same code as in mult counter. So in the mult counter, that is the RTL, you will see there is a section called register write. So here we are writing into the control register and the period register in a particular way. And we are also there is some updation of the counter register. We haven't reached at this stage. There are two registers that we do the register write. So here, instead of naming them as control reg, which you can inside the monitor. Just to differentiate it while debugging, we will name them as control reg underscore mon, because this is the storage element which will monitor the control register. So you have to use exactly the same code, but rename the control reg as control reg mon and the period reg as period reg mon. Here I am assuming that you have already taken care of the port list. One key thing in the monitor is that it will be exactly the same port list as RTL, but the monitor is not driving anything. So you have to think about what we will do about the outputs. Just think about it while you are coding your monitor, and according to that you have to make the port list and the signal directions. Let us look at the next step. In the case of register read, instead of driving values on the read data bus, you will check whether the value driven on the RTL on the read data bus matches the one stored in the corresponding register in the monitor. So in the write, we are going to store the value whenever there is a write on the bus. And when there is a read, instead of providing the value, we will check the value that the RTL provides and see whether it matches the value that we have stored in the monitor. So suppose we are reading the control register, the RTL will drive the value of control reg on the read data bus. Now this bus happens to be an input to the monitor. Just note what I had told you to think about earlier. The RD data bus is the output of the mult counter, but since in the monitor you are just checking, it needs to be an input to the monitor. Therefore you will compare the value of this bus with the stored value of control reg underscore mon. If they do not match, then you will display an appropriate error message. So let us look at the code, what you need to do. So in the mult counter, if you see, if there is a register read, based on the address, the RD data is provided with a value. In the monitor, what you have to do is you have to read the control reg underscore mon, because that is what you will be storing while in register write, and then compare the value with the read data, because in the monitor the read data is an input. You compare the value of control reg underscore mon with the read data and give a message if the value matches or does not match. So that is what you need to do in the monitor. Of course, you need to compare the correct value based on the address. So the code will be exactly the same, other than the fact that instead of driving read data, you will be comparing the value of control reg underscore mon with RD data, which is an input to the monitor, and then give out a display message. So I hope that is clear now. Now let us move on to the next instruction. Once you have implemented a checker for read and write, move to the count strobe signal. So the count strobe signal is the main output of the mult counter. It is the RTL. So you need to check whether the RTL is working properly or not. So this check is the most important check, to check what if count strobe is coming properly. Here you will implement the counter functionality exactly as in the RTL to generate an internal signal called count strobe underscore mon. We expect count strobe underscore mon to be equal to count strobe at all times. An appropriate error message should be displayed whenever this equality does not hold true. So again, let us look at the RTL to see what we are talking about. So this is the code for generating the count strobe. So here we are resetting it, and here we are driving it. So you have to implement the same code in the monitor, but instead of just driving the count strobe, you need to replace it by count strobe underscore mon, and it's not going to be an output, it is going to be a signal which is to be compared with count strobe, which is going to be the input. So let us go through again. The RTL drives the count strobe. In the monitor, you need to make another signal count strobe underscore mon, which will be exactly the same as this code over here. Then you take count strobe and continuously compare it to count strobe underscore mon, which you have written inside the monitor, and flag an error message if they are not equal. So let me repeat. The RTL generates the count strobe. You need to generate count strobe underscore mon in exactly the same way, and then you need to write another block. It can be an always block, it can be a always sequential block, or a always combinatorial block, which you have to figure out, where you will compare count strobe underscore mon with count strobe and flag an error if they are not equal. Now let us move on to the next step. Now it's time to test your monitor after you have written the code in the monitor. To test your monitor, run your existing test cases and verify it does not throw any errors when it should not. Let's run the register read write test case. So you have to write your monitor code in the template that is provided by looking at the RTL, and then click on the run button, which will run the register read write test first. So if you face any errors, you have to go back, make the changes to the code so that the errors go away. Then we run the clock selection test case. So following the same procedure, you click on the run, get the results. If the results throws up an error, then you have to go and change your monitor code, look at the RTL code and the test bench code, and make your monitor error free. In the next, at the same time, you need to ensure, let us look what the next step says. At the same time, you need to ensure that the checker is able to detect genuine errors. To achieve this, introduce some errors in the RTL and run the test cases again. This is a very interesting thing and a very modern way of testing your test bench. So what you do is introduce errors in the RTL and see if your monitor is able to catch it. The monitor will fail to catch if the monitor will fail to catch the errors you introduced in two cases. If the relevant check is not implemented in the monitor, and or the test case does not exercise the specific functionality. In the first case, refine your monitor and add the relevant check. In the latter case, you will need to add appropriate test cases. So this is a very interesting case. Let us take the first one. Suppose you introduce an error in the RTL and then you run your test cases. After you have run your test case, you see that there is no error flagged. What does that mean? That might mean that the proper check is not there in the monitor. So you have to go and edit your monitor to see why that particular error is not being caught. So if you think the check is there, but still it is not being caught, that means the test case that you have written does not exercise that functionality. So for example, if the counter count strobe, there is some error such that the count strobe doesn't work when counter edge has a specific value. Now in your test case, if you don't set the counter edge to that specific value, then you won't catch that error. So you have to write another test case where the counter edge is set to a specific value. So this is what you need to do and submit your mini project to us. We will look at your code and then give you feedback on what you need to do further or whether you have done everything properly. In either case, you will stand to gain a lot by going through this mini project, because this is exactly how you will go about designing in the industry. So thank you for your time, and I hope you are able to finish your mini project on time. Thank you.